All right, so Monday, April 3rd, notes number 5, cardioids and limacons. This is sort of the last new day of stuff. Intersections, you've done intersections before. You set the two equations equal to each other, so you haven't done polar graphs, but tomorrow shouldn't be hard. Today is like the last day of really new stuff. Tomorrow is using stuff you know and a little bit of new situation, and then review on Wednesday, and then test on Thursday. So cardioids, and remember that's not Limacons, it's Limacons. You gotta pronounce it all fancy. Limacons. Friday we did circles and roses. These are the 4 parent functions in polar that we'll need to know. Circles, roses, cardioids, and limacons. And kind of like on Friday, circles was a special case of a rose. It's sort of a one-petaled rose. It's a special case of a rose is how they're related. A cardioid is sort of a special case of a limacon. So these are definitely related, and you might figure that out by looking at their pictures. They look sort of similar. Cardioids, we said this before, I think. Cardio meaning heart. They, if you strain your imagination a little bit, they sort of look like a heart. Kinda. All right, the equation for a cardioid. Let's back up a second. Circles was r equals 7 or r equals 3 cosine 5 theta. Whoops, sorry, that wouldn't be a circle, that'd be a rose. So there's your circles and roses examples. Cardioids have an extra term on there. We've got an a plus b cosine theta. So there's no multiplier on the theta, but there is this extra addition thing out front, a plus cosine and sine. Cardioids are heart-shaped. Cardio, heart. Always go through the origin. So they'll always go back to the origin. Make your cardioids nice and plump. So these cardioids are not like, when you draw a heart and you draw it like that. That's not what these cardioids look like. They are very rounded out, very rounded, plump cardioids. All right, some of this stuff we kind of already know. Cosine, it goes with x-axis. Sine goes with y-axis. So already you'll know the orientation. Cosine is going to be a left-right cardioid. Sine is going to be an up and down cardioid. So this first example, sine, y-axis. And the sine is positive, so it'll be up, an up cardioid rather than a down cardioid. 2 plus 2 is 4, so that's going to tell you like your max value. So the max is going to be 4. And it's going to be up 4 because it's a positive sign. And then the A is how far left and right you go. So together they make the max. And I don't know if I should say left and right, because if it's cosine it would be up and down. That first number will make the sides. Maybe that's a better way to say it. So there's the A. There's our max. And so you really start with 4 key points. We should say it this way. 4 key points. Always the origin. And then the max, which is a plus b. And then the sides, which is just a. That's a better way to say it. So 4 key points because you got 2 sides. So origin, max, and the sides. So let's try this example. So they're equal to each other, so origin, that's what makes it a cardioid. What's the max going to be of this graph? 6. And where's the 6 going to be? Up, down, left, or right? Up. So we'll go out 6. So up 6. How about my sides? 3 on either side. Again, it doesn't matter which one you pick because they're equal on this equation, but we should probably get used to using the A for what we do next. So the sides are 3 out. 1, 2, 3. 1, 2, 3. Okay, so you only got 4 key points, and it kind of makes a T. And so this is where you're tempted to do one of those, you're like, oh, let's just play connect the dots and make a heart. But try to make it very circular, very plump, not like that. So try to get it really circular. Not a squished heart. Circular heart. All right, the next one's got some things that are changed up. What's the max going to be? I would just say 4, but negative 4 is not bad because where are we going to go? Up, down, left, or right? Ooh, careful. Well, okay, so down, well, not down, but the negative, so account for that. But cosine is left and right, so negative cosine would be to the left. So let's go left 4. And how about our sides? 2. And where will we go to get those? Yeah, on the y-axis. Well, I guess it's not really a y-axis in polar, but I know what you mean. We'll go up and down to make the sides. And again, when you put the points on there, it always looks like a T, but you have to know that the shape is a very plump heart, a circular heart. I mean, it's like graphing lines or parabolas or square roots. You get a couple of points, and your brain knows what the shape looks like, so you don't need a whole lot of points, and then your brain sort of takes over from there. Same thing here. The 3 points by themselves aren't a whole lot of information, but you know what a cardioid looks like, so you kind of fill in the rest. All right, how about the max for this one? 8. And where should we go? 8. Left, right, up, or down?
Down.
Down because of this negative, so down 8. And then the sides will be 4. Like that negative doesn't really matter. And you might remember that from the circle. R equals 4 and R equals negative 4 is the same picture. It's kind of the same thing here. That leading negative doesn't really matter. So there's our T. But the graph's not a T. The graph is a very circular heart. Okay, that last one, going backwards here. What's the, is it sine or cosine? Cosine. Positive cosine. And so when we go out 6 with a max of 6, and our sides are 3, So what number goes in front here? 3, and of course for a cardioid they got to match. 3 plus 3 is 6, and then just the 3 out front is the 3. So cosine is still x, sine is still y. Cardioids A and B is equal, and then you start piecing it together from there. A little side note here. The number in front of theta must be 1 for it to be a cardioid. If it's not 1, like this is sort of a combination of, this looks like that piece by itself would be a rose, but that makes it look like a cardioid. It's like, well, that's neither one. You're not going to have to graph these, but you can get some pretty crazy or fun graphs when you start playing with polar. All right, Limacons. The equation kind of looks the same, right? Except instead of A equals B, A does not equal B. Now, here's the easiest way for me to remember what A and B do. If you just had R equals A, what shape would that be? That'd be a circle. So the A is sort of the circle part, and the B cosine theta is sort of the loopy part. That's what I'm going to call it. And so if you could remember that, then these two kinds of Limacons take care of themselves. Limacons without loops, if A is bigger than B, so like if the circle part is bigger than the loopy part, then it's more circular, because A is bigger than B. If B is bigger than A, that's another way to phrase that, then it's got a loop. So the A and the B control whether there's a loop or whether there's not a loop. And if A is equal to B, well then it's a cardioid, and it's like, well, neither one. That's the special case. So first without loops. So that means the circle part is bigger than the loopy part. So they're going to be more circular than loopy. That's how I think of it. So they're not going to go through the origin, but you're still going to have 4 key points. You're still going to have a max. That's A plus B. With the absolute values on there. So the signs control which way it goes. So once you know that, you can sort of ignore the signs and just take the numbers. A plus B gives you the max. The sides are still A, or absolute value of A, but actually that wouldn't really matter because forward or backwards would be on either side. And then, I don't know if you want to call it the minimum, or it does turn out to be the minimum, or the side opposite the max. Let's call it opposite of max, is A minus B. So this A minus B thing, that's the new part. The max and the sides are the same. The same as the cardioid. So this is my summary of all of this. I think this makes more sense. It also matches the cardioids if you do it this way. So add the two numbers together, you get the max. Take A, that gets you the sides, and subtract the number to get the other side. So 4 minus 2 sine theta. Okay, before we get into that, what direction is that going? Good. Why is it going down? Negative sign, we're going down. So this is a downward facing Limacon. 4 is bigger than 2, so it's more circular than loopy. So it's got it does not have a loop. All right, the max is 6, and the max is down because it's a down one. So let's go down 6. about the sides?
4.
4. So left and right 4. And then I guess it's the min. I called it the opposite of the max, but min's shorter to right. 4 minus 2 is 2. So we'll go 2 on the other side. Again, 4 points, kind of looks like a T or a cross, but we know what the shape looks like. So try to make a nice rounded Limacon. All right, let's pull some popsicle sticks on the second one here. Make sure we're all on the same page here. So Evan, first of all, tell me which way this thing is kind of pointing: up, down, left, or right.
Left or right?
And then be more specific. It is a left-right.
What do you mean?
Yeah, it's a good question. It's like, how do I specify? It's based on the positive or negative of cosine. It tells me which way it's sort of pointing. Like this negative sine one was down.
Oh, so it would be to the right?
So this will be to the right. So this would be a rightward pointing or rightward oriented Limacon. Joseph, how about the max?
4.
4. So I'm going to go right 4. JD, how about the sides?
They're 1, right?
The sides are the A.
Oh, so 3.
So it's 3. So 1, 2, 3. 1, 2, 3. And then Danny, how about the minimum or the side opposite the max? The min is A minus B. So 2. And then you just sketch in the Limacon. Again, do not make it flat. Try to make it nice and circular, plump, round, however you want to phrase that. Oops. Let's go in the same order here. Max, sides, min. Why don't you try that third one? All right, we look at the next set. I'm going to pass on the last one. Same stuff. So let's see if we can go backwards on these. Let's see. Sine or cosine?
Cosine.
And positive or negative?
Positive.
Positive. So something plus something cosine theta. Because it's going to the right. Let's see. A plus B is 5, but that's not as helpful yet. Right? If I'm thinking the same order here, max. Maybe that would be helpful. Let's do the same stuff. Max, sides, and min. So A plus B is 5, but that doesn't really help me just yet. How about the sides? 3. So where does that go? Yeah, that's A. That's the first number, 3. Well, now I know if A is 3, then that means B is 2. And now it's just kind of a check. 3 minus 2 is 1. So it takes a little bit of thought on those. How about the next one? What's the sine or cosine? And then positive or negative? So it's a negative sign because it's going down. See if you can figure out A and B from there. So there's the answer to the second one. You try the third one. And you may start to notice that the bigger, like if A is bigger, then it's more circular. And the bigger A is compared to B, the more circular it is. So here A is a lot bigger than B. A is 4 times B. And so this looks like a circle. It's not a circle, but A is so much bigger than B that it starts to look circular. All right, we'll leave the last one alone. Here's another crazy picture. If you got 3 plus 2 cosine 5 theta. So it's like, oh, it's sort of a rose, but it's sort of a Limacon. Like that. We're never going to have to graph that by hand, but you can see kind of the cool picture that would make. All right, Limacons with a loop. Again, if A is littler than B, you have a loop. I just always think that A is the circle part and B is the loopy part. So if B is bigger than A, then you've got a loop. And again, I don't want to just mark those out, but you're still going to have the 4 key points. And they're kind of the same. Max is A plus B. Well, absolute values, so you don't have to worry about signs. Then the sides are A still. And I don't know if you want to call it the min or the loop. I guess we can call it the min. That way it's the same as the other. And it's still B minus A. Or what are we doing the other one? A minus B? Let's call it A minus B still. That way you'll get a negative number, and that might remind you that there's a loop. So instead of going out, there's this loop thing going on. So it's still max sides min. Max sides min. So first one. What's our orientation on this first one? Which way is it sort of pointing? Up, down, left, or right? Up because of sine. And then let's work through our key points here. The max is 1 plus 3, which is 4. The sides are 1. And the min is 2, or negative 2 if you want to keep with the A minus B thing and have that remind you that it's a loop. But if you just said 2, that's fine, because I'm looking for the picture. So 2 means we're going to go up 2, right, on the same side as the max, because that's going to give us the loop. Okay, so these get a little tricky to draw. They also always go through the origin. So if you want to add that as a key point, although putting it on there makes it, I don't know, even trickier. The order, I think it's helpful to graph them like in the order that you see them. So like from the max, circle around to the sides, and then make the loops. This is tricky for some. All right, that second one. What's its orientation? Which way is it pointing?
Left.
All right, so we're heading left. Max, sides, min. Oh, let's pick on some people here. So Austin, what's the max? 3. Noah, how far out do we go? What are the sides? 1. And Angel, how about the min? Also 1. So the sides being just this one, the min being 2 minus 1. Okay, so we're heading to the left, so I need to go out 3. There's my max. My sides are 1. So 1 on each side. And the minimum is 1. From the pole, am I going left or right to get to the minimum? In order to make a loop here, I'm going to go left. Okay, and then again, I think if you'll graph them in that order as well, max to sides to minimums. So max, and always make them circular, right? You're not playing connect the dots. So max, circle to the inside and circle back. Max, sides, minimum. Why don't you try the third one? Pictures are gradually getting better. It helps to have lots of example pictures, and that'll be that way on the test as well. The ones where you sort of have to work backwards. That way it sort of reminds you to make them very round. You're not playing connect the dots. All right, once again, I think we can pass on that last example. Any questions on these? So max, sides, and min is kind of the trick to all of these today. Okay. Sine or cosine on this first write the equation example? Cosine. Positive or negative? Negative, because it's going to the left. And I don't know. Some people can just jump right in and write the equations. I still like to go max, sides, and minimum. Or at least max and sides. 1, 2, 3, 4, 5, 6, 7. So the max is 7. The sides are 2. Okay, well the sides being 2, that's my sort of key point to the whole thing here. Thank you. So what's the coefficient of the cosine have to be? The max is 7, the sides are 2. 5. And then we could check. 2 minus 5 better be negative 3. 1, 2, 3. Yeah. You try the second one. 2 plus 4 sine theta. Let's do one more. I don't want to cut it too short here. So that's another plus sine one. So plus sine. Let's see. The side, some of you are probably doing this already where you skip around and just, sides are 1. The max is 4. So 1 plus 3 sine theta. Let's back up all the way to the cardioids. And so you don't even have to know the difference between a cardioid and a limacon, really. If you want to do max, sides, and minimum on all these, 3 plus 3 would be the max. The sides would be 3. And the minimum would be 0, which would put you at the origin. So in some ways you don't have to think of them as two separate shapes. They're all just limacons. Some have a loop, some don't have a loop, and in a special case they go back to the origin. So rather than try to think, oh, it's two different shapes today, no, it's one shape. Find the max, find the sides, find the minimum, and occasionally you hit this special case where it goes perfectly back to the origin, and that has a special name, cardioid, but it's still like a specialized case of the limacon. And then there's that last picture. Again, you're not going to have to graph those, but that's that combination of it's sort of a rose, it's sort of a loopy limacon, and yeah, sure enough, you get crazy looking graphs. Kind of fun. Alright, so worksheet whatever's next. Today's assignment, worksheet 5.